Hello everyone, my name is Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is all unique permutations of an array. First of all, let us start by understanding the question. What does question say? Given an array ARR of length n, find all possible unique permutations of the array in sorted order. So basically, we are given an array which contains n elements and we need to find all unique permutations. Okay. Also, we need to return these unique permutations in sorted order. A sequence A is greater than sequence B if there is an index I for which A of j is equal to B of j for all j less than I and A of I is greater than B of I. We will understand this in depth later on while understanding the concept. Basically, if I have 1, 2, 1, okay, then there can be how much? Factorial 3, that is 6 permutations. But I have to take only unique permutations. Now, since 1 and 1 is repeating here, so number of unique permutations would be factorial 3 divided by factorial 2, that is 3. And these are the 3 unique permutations. And in sorted order, it would be something like this, okay? For n equals to 2, here both the elements are unique, so there will be factorial 2 permutations, that is 2. So here we have written them in the sorted order. You don't need to read input or print anything. You only need to complete the function unique permutations that takes an integer n and an array A of size n and returns a sorted list of lists. Okay. Why lists of list? Because this list will contain all the permutations and each permutation will itself be a list. So it will be lists of lists containing all unique permutations of the array. The expected time complexity is n into factorial n and expected auxiliary space is also n into factorial n, and the constraints are given here. So now if we think about solving these problems and see, basically what they are asking is we need to generate all unique permutations of the given array. Now why unique? Because see here if I write down all the permutations, then there would be factorial 3 permutations because all 3 elements are different. So it would be 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2 and 3 2 1. These are the 6 different permutations, right? But here if you look here, there are 2 1s and 2 2s. Okay, so overall for 4 elements then can be factorial 4, that is 24 permutations. But since here there are 2 elements repeating, so here the total number of permutations would be factorial 4, it would be factorial 4 divided by factorial 2 into factorial 2. Why? Because these are the repetitions. So that is 24 divided by 2 into 2. That is nothing but 6 unique permutations. Okay. So here there will be only 6 unique permutations. That's why they have used the word unique. Another term which they have used is that we need to return these unique permutations in sorted order. Now, if I want to compare 2 permutations, which one is greater and which one is less, so how can I compare it? See, all the permutations will have n elements, right? Okay. So let's say n is equals to, let's say 8, okay, and these are the 2 permutations which contains n elements. I want to compare which permutation is greater than which one. So how can I compare? So basically what we do is we move from left to right, and when we find the first mismatching number, then in that case whichever permutation has that number greater will be the greater permutation. For example, if I have 1 2 3 4 5 and let's say 7 and 8, okay, and I have 1 2 3 4 8 5 and 7. So here both of these are permutations of length 7, but here if I move from left to right, all these are same. This is the first difference, okay. So here 8 is greater than 5, so this second permutation is greater than this, okay. So in sorted order, this will come first and this will come second, okay. So basically what I'm trying to say is this will come after this. Why? Because this is greater, because where the first character mismatches, there we compare, okay, irrespective of what the characters are here. Okay, got it? So this is what do we mean by comparing. Now we need to return all unique permutations and we need to return them in sorted order. So first of all, understand one thing. See, what is one way we can do is by recursion. By recursion, we can generate all permutations and put them in a set. Now why set? Because set contains only unique elements, right? So whenever a permutation will be repeated, set will count only once, okay? And then print them in sorted order. But you see here, if you look at the time complexity, expected it is n into log n, and expected auxiliary space is also n into log n. If you put it in a set which will maintain a sorted order, there would be some term of logarithmic, okay? But here it is not said that, so we cannot do that, right? We need to think of something more efficient. So what can we do is, see, first of all, what I will do here is, I will, let me write down on a new screen, okay? I will take, let me take this example, n equals to 4 and I have 1, 2, 1, 2. So what I will do is, I will first of all sort this array. So this will become 1, 1, 2, 2. Now, I will recursively try to fill all the 4 positions, and when all the 4 positions will be filled, I will try to recursively fill all the 4 positions with all different values. That is how we generate all the permutations. And while filling them, when I fill all the 4 values, I will add that permutation to my answer list, okay? Now what smartly we are going to play here is, we are going to do something such that we generate only unique permutations. Like there is no question of repeating permutations, first thing. Second thing, since we have sorted them and now we are going to generate the recursion, we will also get the unique permutations in sorted order only, okay? How? Look at this example, it will be very clear, okay? So I have 1, 1, 2, 2, okay? I want to fill 4 positions, okay? Now for this positions, I have 4 options, okay? So there will be 4 recursion tree, right? In the first recursion call, I will use a for loop in which I will first time place this at the first position, then this at the first position, then this at the first position, and then this at the first position. Are you getting my point? If I have 1, 2, and 3, 1 can be at the first position, or 2 can be at the first position, or 3 can be at the first position, because I can have 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So all 3 values can be at first position. So I will fix an element at the first position, then move on to second position, fix an element there, then move on to third position, fix an element there, and then whatever permutation is generated, I will add it to my answer list, okay? So now, also whichever element I add to my permutation, I will mark it as visited or counted, okay? So that because I cannot repeat any element, right? So here, first of all, let us say I decided to use this one, okay? This one at the first position, or let me write it as like this, A1A, 1B, 2A, 2B. So here I have used 1A and I have 3 positions empty. Here I have used 1B and I have 3 positions empty. Here I have used 2A and I have 3 positions empty, and I have used 2B and I have 3 positions empty. Now listen to me here carefully. Does this make any difference if I place this 2 or this 2? What I am trying to say is, if I place 2A here, the remaining is 1, 1 and 2. So with these 3 elements remaining, I will have some permutations here. With 1, 1 and 2, I will have 1, 1, 2, I will have 1, 2, 1, I will have 2, 1, 1. Okay, I will have 3 unique permutations. Now, irrespective of whether this is 2A or 2B, these 3 will be same. Basically, if I replace here 2A or 2B in the further recursions, I will get the same permutations, but I want only unique permutations. It means I should not consider this case of taking 2B at the first position, right? So what is our criteria of not considering a case? If A of I is same as A of I minus 1, and if A of I minus 1 is not considered yet, then I will not consider A of I at that position. Okay, this is my ith index, this is my I minus 1th index. If A of I and A of I minus 1 are same, and if A of I minus 1 is not taken yet, for example, here when I am taking 2B, 2A is not taken yet. So if I take 2B, it is same as taking 2A in some another case. Are you getting my point? If I had used 2A previously, then I could use 2B, which the cases will be covered here. But without considering 2A, I should not take 2B. If 2A is not taken in the permutation yet, I will not take 2B, because that will cause repetition. Similarly, here I have not yet taken 1A, so I will also not take 1B, because the recursion, because the permutations generated here and here will be same, because this 1 and 1 are same. So I will not take this. Okay, so these 2 cases are gone. Now from here again there will be 3 cases because I have 1 1 and 2 2s remaining. So let's say I decided to, now 1A is fixed here. Now let's say I decided to take 1B here. Okay, so it would be 1A, 1B and 2 empty places. I can take this, yes. Now I can consider 1B. Why? Because 1A is already considered. So it will not generate repetitive permutations. Okay. When it would generate repetitive permutations, see, here I have 1A, 1B. Here what would have happened? I would have taken 1B and then 1A. So this would generate repetitive permutations, right? So that's why I have not considered this. But if A of I minus 1 is same as A of I, and if A of I minus 1 is taken in the permutations, then I can take A of I also. Okay. Here at the second position, I decide to take 2A. So it will be 1A, 2A and 2 empty positions. Now here I have 1A, I decided to take 2B and then I have 2 empty positions. Now again tell me, shall I take 2B? No, because here in this permutation still 2A is not taken. So 2B must not be taken. Okay, so I will not go further here. Okay, in fact we will not go on this path only. Okay, similarly here I have 3 cases. Okay. Okay, this is not considered only. Okay, so let's not take it. Okay, and this is also not considered. Here I have 3 more cases. I take 1A. Okay, then I take 1B. But I cannot take 1B without considering 1A because this will generate repetitive permutation. So I will cross mark here. Or I take 2B. Now 2B is allowed here. Why? Because 2A is already taken. So it will not generate repetitive permutations. Okay, so I have this 2 and I have this 2. Now again, here I have 2 choices, either 2A or 2B. But see, let's take 2 choices. So I have 1A, 1B, 2A or 1A, 1B, 2B. But 2B I should not take because 2A is not taken. So I will not go further here. Okay. Here I have 2 choices. Which 2 choices? Either to take 1B or 2B. I can take any of them because 1A and 2A both are taken. So I say 1A, 2A, 1B. 1A, 2A, 2B. Okay, this is, we are not going further. Now here also I have 2 choices. 2A and 1A are taken. So I can take 2B as well as 1B at this position. So it would be 2A, 1A, 1B, 2A, 1A, 2B. Okay, this we are not going further. Here, see, I can take 1A or 1B, but I will not take 1B. Why? Because see, this will be 2A, 2B, 1A. And 2A, 2B, 1B. Now I cannot take 1B because 1A is not taken. Okay, and here still 1 empty position is there. Now this we are not taking. Now at the empty position only remaining element will come. So I will take 1A, 1B, 2A, 2B. Here I will take 1A, 2A, 1B, 2B. Here I will take 1A, 2A, 2B, 1B. Here I will take a 2A, 1A, 1B, 2B. Here I will take 2A, 1A, 2B, 1B. And finally here I will get 2A, 2B, 1A and 1B. If I write it generally, then 1 1 2 2, 1 2 1 2, 1 2 2 1, 2 1 1 2, 2 1 2 1 and 2 2 1 1. Okay, if you look here, we have generated only unique permutations. We should get 6. Why? Because there are total 4 elements, so factorial 4 permutations should be there, but 2 is getting repeated 2 times and 1 is getting repeated 2 times, so overall number of unique permutations will be this much. That is nothing but 6. So we have got 6. Also, since we sorted the array initially, so here the order in which we will get is sorted. So here you see you have 1 1 2 2, which is less than 1 2 1 2. Why? Because here we have 1, here we have 2. Now 1 2 1 2 is less than 1 2 2 1, because here we have 1, here we have 2. 1 2 2 1 is less than 2 1 1 2, because here we have 1, here we have 2. 2 1 2 1 2 is less than 2 1 2 1, because here we have 1, here we have 2. 2 1 2 1 is less than 2 2 1 1, because here we have 1, here we have 2. So we get in the sorted order. So whenever we generate this much permutation and whenever we are at index n, we will add this to our answer list. Okay, so we will add this permutation, then 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 we will add this permutation, and then we will add this permutation, and finally we will return our answer vector, which will contain unique permutations in the sorted order. Now let's look at its actual implementation. So if we look at the actual implementation, then this is the function unique permutations which we have to fill, where we have to return a list of lists where we are given array and n as input. So what I have done is I have taken 2D vector as my answer, in which I will enter all the permutations. I have taken one vector p which will store all the permutations. I have taken one boolean array visited which will mark visited whenever I will consider an element in my permutation. Okay, initially I have marked all of them as false. I have sorted the array as I told, and I have called the permutation. So I have passed the visited array, I have passed the array, I have passed the answer vector 2D vector, I have passed the permutation vector, I have passed the n total number of elements, and I have passed the starting index. So first of all I want to fill 0 index, that's why I have passed 0. Once I fill 0, I will pass 1, then I will pass 2, and so on. Okay, and here in my p vector I will keep on adding the elements whichever I consider. So p will contain the current permutation, and whenever I get a particular permutation field I will add it to my answer. Okay, so now let's look at this permutation function, and finally I am returning the answer 2D vector here. Okay, so now if we look at this permutation function, so here I have I, that is the current index to be filled, n as the total number of elements, permutation, answer, array, and visited. First of all, if I is equal to n, it means I have filled already n elements, because my index will range from 0 to n minus 1. So whatever permutation is generated in vector p, I will push it to my answer and I will return from here. Otherwise, I will take one variable j and I will go through all the elements from j equal to 0 to n. Why? Because my elements are sorted in nature. So the first, if I want the answer in sorted order, the first preference I should give to the first element which is not yet selected. Okay, so every time I will pass the loop from 0 to n minus 1, and if it is not visited, I will consider adding this element to my answer. So what I will do is, first of all, if j is equal to 0, there is no previous element, so there is no question of repetition. So I will push back this element to my answer and mark it as visited true, and I will call permutation on I plus 1 and p, answer, array, and vector. Okay, and after I backtrack, for example, here first in the first place I added 1 here. Okay, and the 3 elements were remaining, and I called the recursion here. Then this further recursion will be called. But when I backtrack, at that time afterwards, when I go to a new branch, I will add 2 here. But when I add 2 here, I have removed this one from my permutation, so I have to mark this visited as false again, right? So after coming back from this permutation, I will mark visited of j as false, and I will pop out that element from my answer vector. Okay, it would be the last element. So that is when j equal to 0. Now if j is greater than 0, what we said, if I am taking a particular I index element, and if the previous element is same as that element, then we will only consider this element if this is already added to my permutation. Okay, so there is no repetition. If ith element which I am considering is not same as I minus 1, then there is no question, you can consider it. So first of all, the element should not be considered in the permutation yet. So if visited of j is false, if j is greater than 0, then I need to see either array of j is not equal to array of j minus 1, well and good, or if it is equal to array of j minus 1, then j minus 1 element should be considered. So v of j minus 1 must be equal to true. Either in these conditions, what I can consider the jth element. So I can push it to my answer and mark visited as true and call permutation on I plus 1 index. Again, during backtracking, I need to mark this visited as false, and I need to pop out the element from the permutation. So in this way, what will happen is, whenever I will get I equals to n, I will push that permutation into my answer vector. And finally, this will generate all the permutations, and I will return it to my return it from my main function. Now what would be the time complexity here? You see, every time when I came I equals to n, I am adding a permutation to my answer. Okay, so there will be factorial n permutations. So I will call this function factorial n times at max if all the elements are unique. So that is equal to factorial n. So this function will be called, this will be called factorial n times, right? And whenever I call this function, if this is not equal to this, I am running a for loop of size n. So I can say it is factorial n into n. And what is the auxiliary space? see, if I look at my answer vector, then my answer vector contains how many factorials? At max factorial n factors, at max factorial n permutations. Why? Because if all the elements are unique, it will contain factorial n permutations, and each permutation is of length n. So this will be my auxiliary space. Obviously, here there would also be some time taken to sort the array, then there will be some time and space for the recursion, but those will be very small as compared to this. So this would be the effective time and space complexity, the auxiliary space complexity. Now let's submit this code. Okay, so let's submit it. Okay, we have solved this question successfully. I hope you have understood the solution completely. Thank you.